Okay, I'm now going to go through example 3. So this one, actually the example is inside the textbook, but I want you to look at it, how is it being done when I explain. So the variable x and y are connected by this equation. Okay, this is the equation that we are given, okay, where a and b are constant. Where the graph of something xy against x is drawn, the resulting line passes through the point of this and this in the diagram. So I want you to take note that when we plot something against something, we will usually put the big Y against the big X. That means this is actually a big Y, this is actually a big X. Okay, so now we just need to know that this is actually a straight line graph. So a straight line graph is actually y equals to mx plus c. So given the 2 points there, we can actually find the gradient of this line, which is using the formula y2 minus y1 over x2 minus x1. Okay, so I will just use the number there. So 2 minus 4 over 6 minus 2. So the gradient of this line will just be half. Okay, will just be half. Okay, just be negative half. So given that the gradient is negative half, using the formula y equals to mx plus c now. So I know that my gradient is equals to negative half. I can just sub in any of the point 2, 4 or 6, 2 inside the equation. So I will just sub in 6, 2. So x equals to 6, y equals to 2 plus c, so that I know that c is equals to positive 5. So the actual equation now, the straight line is y equals mx plus c. Now it's written as y equals to negative half x plus c. But do remember that we have used the xy, the variable xy as a big Y and x as the big X. Okay, so we just need to substitute back, so to do a comparison with the original equation. The original equation is actually this red color highlighted equation that I have drawn. So now xy is the big Y, so I substitute xy back. Okay, use the small x, xy equals to negative half, okay, small x here, plus c. Oh, sorry, the c I should have written as 5. So plus 5. So when I compare this equation and this equation, I saw that they are making y the subject. So what I need to get rid of on the left hand side, xy, I just need to divide it by x throughout. So xy divided by x will be y. And this negative half x, okay, when I divided by x, I will left with negative half. Here I'm left with negative half. And this 5 here, when I divided by x, it will be plus 5 over x. So now, as I write down rewrite the equation to the same form as which one? Same form as the highlighted one. Highlighted one is y equals to a over x minus b. When I do a direct comparison, I will know that the a will be equals to 5 and the b will be equals to half. Okay, this is for part 1. Okay, and for part 2, I want to find the value of x when y equals to 6 over x. Okay, using the graph, the graph already plotted the xy against x, right? So now I given y equals to 6 over x. So if I want to find the y value, this y value okay, let's look at the graph first. This 4 is actually xy equals to 4. This x here will be x equals to 2. Okay, because based on the two axis that is given as the variable here. So this 2 here, which is the big y axis, is actually xy equals to 2. Then the x will be given as 6. So now when I given this equation here, so I want to find the value of y. So I will say that xy, if I move my x over, okay, so xy will be equals to 6 now. This is actually my big y, right, equals to 6. Based on the equation, the straight line equation, x plus 5. xy is equals to y, so I is equals to 6. When I substitute my 6 inside here, 6 is equals to negative half big X plus 5. Okay, so move over, become plus 5, move over, become minus 5. So times 2, negative. So negative 2 will be equals to the big X. Okay, negative 2 will be equals to big X. But we know that this big X here is actually the X value. The X value. So actually the X will be equals to negative 2. Okay, therefore, substituting x equals to negative 2 into this equation, 6 divided by negative 2, the y will be equals to negative 3. Okay, if you are not sure or not clear, please try to listen again so that you understand.